Okay guys, so we're going to start looking at Venn diagrams today. So Venn diagrams you might have seen before. It's essentially what we were talking about last time, our universal set containing all the information, and then we have sets of information within there. So I might have set A and set B. So this is my universal set, there's my set A, there's my set B. Okay? Or it might be that A and B, so this might be odds, this might be evens. Your choice entirely, and then everything outside might be like, I don't know. If it's just talking about odd integers and even integers, then you might say you have a half out here or something like that. Okay. Another example of the way a Venn diagram might be set, which is the one you usually see, which is that one over there, where you've got A and B, but you might have stuff that they both share. Okay, so say if A was talking about multiples of 3 and B was talking about multiples of 5, then the number 15, where would it go? It would go in both A and B. So it would go in this circle here. That way it's still in A, but it's also in B. Okay? And if you have 3 sets, which we've done previously, you usually see something like that. Dun, dun, dun. Some of you might recognize that shape. It is quite a designer shape. Okay, mine isn't that even, but here, it's just a sketch, it's all good. So this would be A, this would be B, this would be C, and this would be my universal set. So you may notice that I'm drawing boxes around all of them. That's because you must always remember about the universal set. So if that box is not drawn, that's not a true Venn diagram. Okay, so you've got those, and then one other option you might have is, say if I had something like this, where this is A and this is B, and you've got B inside A, okay? So this is when you would talk about subsets, because you're saying this set is completely contained within this one. So say if A was all multiples of 2 and B was multiples of 8, okay? So 8, 16, 24, 32, 40, all of these numbers are also multiples of 2. That's why B is contained within set A. Hopefully that makes sense, okay? So I'm just kind of showing that you do have different types of Venn diagrams. But we're just going to go through a few examples, and then I'm going to let you work on the sheet. So may you have fun. Okay, so we have set A and set B. So I'm just going to read set A and set B from there. It says copy and complete the Venn diagram, and it says include all the whole numbers from 1 to 10. So the first thing I want to note down is if this was, say, some sort of assessment paper, I usually give you on paper, you would already have A and B written down. If I didn't have A and B written down, I would write it down again. But I do want to write down the universal set just in case I forget about this line that they just put there where it went include all the whole numbers from 1 to 10. So I know that my universal set must contain all the numbers between 1 and 10. Okay, so I'm now going to draw my Venn diagram. So here's my universal set. This is A, and this is B. Okay, so I am going to make my A red, okay? So I'm going to circle any numbers in here that are part of set A, sorry. So set A is 1, so let's circle the 1. It's 4, so let's circle that 4. It's 5, it's 7, and it's 8. Okay, and then for set B, I'm going to have it in green. So I have 2, I have 6, I have 8, and I have 10. Okay, so when you are looking at completing a Venn diagram, one of the first things you want to do is try and work in and then go out, okay? Because it's very easy to say the universal set contains 1 to 10 and then put 1 to 10 all in this box. But you can't repeat numbers in Venn diagrams, so then you'd have to erase part of it and then put it inside. So usually you work from the innermost and then you work out. So the getting to the universal set should be the last thing that you do, okay? So the first thing I want to look at is I want to look at this part here, okay? So I need something that is both part of A, because there's your circle for A, but it's also part of B. So do I have any numbers in here which are both red and green. Okay, so when I'm looking, there's only this one, okay? So this 8 must be the thing that's in between. Some of you might want to do this, some of you might not, but quite a few people do tend to cross out any numbers that they've put in the diagram because they don't want to duplicate anything. So if you do want to cross it out, that's fine. If you don't, you don't have to cross them out, okay? So I've got my shared number. So now I'm going to just do my A because I'm first in the alphabet. So all these reds are going to be outside here because they're not part of B, but they are still part of A. So I know that this section of A is also shared with B, but the rest of this section is just A. Okay, so I've got 1, 4, 5, and 7. So that's 1, 4, 5, and 7. Okay, so even if you just want to double check, you can always just do that, and you can say, well, if I compare it to set A over there, it is 1, 4, 5, 7, 8. So you are satisfying that whole part of set A, okay? And then you have set B, which is all your green. So I know the part that's shared with A is 8, but outside that, it should just be the rest of the green. So I've got 2, 6, and 10. So I've got my 2, 6, and 10. And if you do want to check those, then obviously you just need to highlight just B and double check that it matches up with that over there, which is 2, 6, 8, 10. Yes, it does, okay? So my A and my B is done, but I haven't stopped because I've still got these 2 numbers here. So if they're not part of set A or part of set B, they just go on the outside. It doesn't matter where they are as part of the universal set. You could pop them up here, down here, it doesn't really matter, as long as you have them within that rectangle. Okay? So that would be the first one. Next one. So it says whole numbers from 1 to 10 are organized into 2 sets. Okay, so first piece of information, that is my universal set. So my universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's my universal set. It says set A contains all the odd numbers, set B contains all the numbers greater than 4. Okay, so A is just the odd numbers. Because they haven't actually given me a list, I'm going to write it down. Okay, so set A is all the odd numbers. So it's 1, 3, 5, 7, 9, right? And set B is all the numbers that are greater than 4. So that doesn't include 4 because it's saying greater than. So it will be 5, 6, 7, 8, 9, 10. Okay. Now I'm going to use my trusty A, and I'm just going to take it from the universal set. So I've got 1, 3, 5, 7, 9. Okay. And then I've got my B, which is my green, which is 5, 6, 7, 8, 9, 10. Okay, and now I've got everything that I need to draw my Venn diagram. So there's my universal set. There's quite a few, obviously, that are mixed. So they do actually kind of give it to you. Just got to show the intersection. So I've got A and I've got B. So first of all, I want to find out what both of them share. So both of them share 5, 7, and 9. So I've got 5, 7, and 9. So let's cross those off. Okay. The remainder for set A is just 1 and 3. So they're going to go out here. Let's cross those off. And then for B, I've got 6, 8, and 10. So I've got 6, 8, and 10. Okay, and then what am I left with? I'm just left with 2 and 4. Okay, hopefully that makes sense. Obviously, any questions, please let me know. So that is the first 2. That's how to make your own. But what if you had to read a Venn diagram? Whoops. Sorry about that, guys. There's me trying to scroll down instead of scrolling down. I'm taking Windows. Okay, so last part is 3. So whole numbers from 1 to 20 are organized into sets as shown in the Venn diagram. It says list set E and list set S. Okay, so They don't actually tell me to list anything but set E and set S. Okay, so let's just get that Venn diagram drawn. I'm going to pause while I get this Venn diagram drawn because it's going to take me a little while. Okay, so I've drawn it out. Obviously, they are talking about E and they're talking about S. You'll notice this is epsilon. It's not actually an E. I know some people seem to think it's a fancy E. It's not a fancy E. It's epsilon. It's a Greek letter, okay? So the Greek letter, it's the same way I wouldn't call alpha A and I wouldn't call beta B, okay? Alpha is alpha, beta is beta, A is A, B is B, okay? So they are just talking about S and E. So first of all, they want you to list E, okay? So for E, I am just going to look at this circle right here. So I'm going to list every single number in here. As I've said, it does not need to be in order. So I've got the 4, the 16, the 2, the 8, the 6, the 12, the 10, the 14, the 18, and the 20, okay? And that would be set E, okay? And then for set S, I've only got 4 numbers in that set, so it's just there. It's just that circle. So it'll be 1, 9, 9, 4, and 16. Okay, super easy, okay? Venn diagrams are so easy. Once you kind of just get into the rhythm of it, it'll just make complete sense, okay? But that should be enough to allow you to work on the worksheet today. So obviously, make sure you have some notes and then get cracking on the worksheet and then take photos and submit them, okay? Take care, guys. Toodles.